everybody. I am a teacher from Elm Online Academy, and today we are going to have the IGCSE chemistry notes. This is the chapter 2 of chemistry contents, and in today's video we are going to have a look at the second chapter, which is about the atomic structure. This is the topic which we have been doing since the start of the chemistry. So first of all, I am sharing with you the contents of this chapter. So you can see here, these are the contents which are included in chapter number 2 of atomic structure. So we'll discuss today about the atoms and the elements, in which we will look about the definitions of atoms, elements, compounds and mixtures. Second, we'll discuss about the isotopes, and third, we'll move towards the electronic configuration of the different elements. So first, have a look at the simple definition of the atoms, elements, compounds and the mixtures. First of all, you should know about what is an atom. We'll start with the atoms. In this, you will learn that the matter is made up of tiny particles, and these particles are known as atoms. So atoms are known as the smallest particles. These are the smallest particles from which matter is made up of. All the matter that are present here is made up of the tiny particles, which we call as the atoms, and each atom has a nucleus, and electrons are also present or revolve around the nucleus. Nucleus hold the protons and the neutrons. Like this is the simple structure of any atom. This is the nucleus, in which we have neutrons plus the protons, and around the nucleus we have the shells in which electrons are present. So these are the electrons that are present around the nucleus, and electrons revolve around the nucleus in different shells, and neutrons and protons are present inside the nucleus. So this is the atomic structure of any element. So this is about the atoms. Next, I will discuss with you about the elements, compounds and the mixtures. So the next is about the elements. Elements, we have all the substances that can be classified into the three types. First, elements, second, compounds, and third is the mixture. So first of all, we'll start with the elements. Any substance is made up of atoms that contain the same number of protons, and they cannot be split into the anything simpler. This is the basic definition of any element. And element consists of only one type of atom. One type of atoms are present in the elements. They cannot be broken down into the simpler substances. We can't divide the elements, or each element has also own symbol that is for their representation. For example, in our periodic table we have total 118 elements, and for hydrogen, H is for the hydrogen. This is the first element of our periodic table, and O is for oxygen. So elements can be classified in our periodic table either as the metals or as the non-metals. This is the basic classification of in our periodic table. So I'm again telling you about the elements, definition of elements. They are consist of one type of atoms, and they cannot be broken down into the more simpler substances by any chemicals means. So next, I'm moving towards the compounds. Compounds. Okay, so compounds are formed when two or more different elements are chemically combined. When different elements chemically combine together, they form the different elements chemically combined, they form the compounds. Like for example, we have the example of the simplest one, which is the water, H2O plus we have CO2, carbon dioxide. Next we have HCl, hydrochloric acid. all these are the compounds. Carbon dioxide, hydrochloric acid, sulfuric acid, all these are included in the examples of the compounds. Compound is by the chemical change. Compounds cannot be separated by their elements through any physical reactions. They can be separated only by chemical reactions. So their properties are different than that of the compounds they are made from. When carbon dioxide is formed from the carbon and the oxygen, they have different properties. They don't show the properties of each element that is present in it. So these are the compounds that are formed when two or more different elements chemically combined in the fixed ratio to form a new substance. So one more thing which is about compounds is that they have the fixed ratio. In compounds we have fixed ratio, but this does not happen in case of mixtures. Mixtures have different ratios, they are present in it, but compounds have the same ratio or fixed ratio. For example, in hydrochloric acid, one hydrogen and one chlorine is present, so 1:1 in case of hydrochloric acid, and in case of carbon dioxide 1:2, 1 ratio of carbon and 2 ratio of oxygen is present there. So next we'll move towards the mixtures. Mixture. First of all, the definition of the mixture. Mixture are the combination of two or more substances combined together. They are not chemically combined in case of mixtures, but there is no chemical bonding or chemical reaction that is present in the mixture, just a combination of two or more substances. Mixtures can be separated by physical methods, for example filtration, distillation, without breaking any chemical bonds. Separated by physical methods. And the third one, the properties of the mixtures are based upon the properties of the elements that are present in it. For example, we have some alloys that are the mixture. Alloys are the mixture of different metals or non-metals. We have a seawater. Seawater is a mixture of different salts that are present in the water. So moving towards the next, we will discuss about the difference in the mixture and the compounds. I have some differences that are present in the mixtures and the compounds. So these are the mixtures and these are the compounds. First difference is it contains two or more substances. Mixtures contain two or more substances, but in case of compounds we have just one substance. After the formation of the compound, there is only one substance that is present there. Mixture contains a mixture of two or more different substances. No chemical change will be there in case of mixture. Mixtures are just mixed together, so there is no chemical change. But in case of the formation of the compounds or formation of the new substances, that involves a chemical change. There is a chemical change that happens in case of compounds. Third one is the properties of the mixtures are of the individual elements or the compounds that are present in it, but in case of compounds, the properties of the new substance are very different from either of the elements that are used to form the substances. So this is all about the elements, compounds and the mixtures. Next I will show you or by the particle diagram showing the elements, compounds and the mixtures. This one, suppose as I told you earlier or in the first, suppose this one is the atom. So this is the atom, and when atoms combine together they form the elements. Like when same type of atoms are present, they form the elements. When elements combine together, they form the compounds. Like you can see here, this is the molecule, this one is the molecule. Molecule have two or more different atoms that combine together, and Compounds are formed like, I'm drawing it with a different color like this. Suppose this one is the compound. Yeah, suppose this is the compound. So compounds are formed by different elements that combine together chemically. Molecules, like for example we have H2, hydrogen, Cl2 is example of molecules. Compounds, we have HCl, we have carbon dioxide, all these are the examples of the compounds. And in case of mixtures, we have different elements, like you can see here, I'm drawing it with the different color. So this is the example of mixtures. So this is the particle diagram showing the elements, compounds and the mixtures. So now we'll move towards the atomic structure of the atomic structure of the elements, of the compounds and also of the atoms. So first of all, I will share with you the diagram or the particle diagram that shows the atom, electrons, protons and also the neutrons. Alright, so this one is the atomic diagram of the atomic structure, in which you can see here in the center we have the nucleus. This one is the nucleus, and nucleus contains the protons and the neutrons. Protons have the positive charge and neutrons have neutral charge, and electrons that are present or that revolve around the nucleus in different shells, we call them as the electrons, and electrons have the negative charge. So overall charge on the nucleus is positive because protons have positive charge and neutrons has neutral charge. So the overall charge on the nucleus is positive and electrons are attracted towards the nucleus because of its negative charge. In the first chapter or in the previous video, we have learned that matter is made up of tiny particles, and these particles are known as atoms, and atoms are the smallest particles. So each atom contains a nucleus, and the electrons around the nucleus holds the protons and the neutrons, as you can see here, and electrons are placed in the shells as shown by the diagram, as you can see here on my screen. So this is the atomic structure of any atom. As you can tell by the diagram above, electrons are the negatively charged while protons are positively charged, and neutrons however are neutral and they have the no charge. So the symbol for the proton is P. P is the symbol that is used for the protons, and proton has the charge which is positive 1 for 1 proton. Neutron has the symbol N, right? And the charge on the neutron is neutral. So you can say that there is no charge or neutral charge is present on the neutrons. And for electrons, electrons are represented by E, and they have the negative charge. Negative charge is present here on the electrons. -1 with small n you can represent the neutrons, and with small e you have, this is the symbol for the electrons. So this is the charge that is present on the protons, neutrons and the electrons. So next we will move towards the relative mass of these different particles that are present there. So about the relative mass, you can see here, or the relative charge or relative mass that is present on it. If we talk about the relative charge, that is +1 on the protons and neutral on the neutrons, and electrons have the -1 charge. So electrons move very fast around the nucleus in different orbital paths that we call them as the shells. As you can see here, these are the shells in which electrons move, and all the elements are measured relative to the mass of the carbon-12. So the relative atomic mass has no units. There is no unit of the relative atomic mass, and the relative atomic mass of different structures are there. The relative atomic mass of proton is, now I'm showing you the relative atomic mass. So here is the relative atomic mass. Relative mass For protons, we have the relative mass of 1. For neutrons, the relative mass is also 1, and for electrons, the relative mass is 1 by 1850. So this is the relative mass of the electrons, protons and the neutrons, and these are measured, all the elements are measured relative to the mass of the carbon 12 atom. This is the standard one. So relative atomic mass has no units. You can say that it's by 1850 or 18 जो है वो mostly we have the 1840, that is the mass, relative mass of the electrons. Mostly 1840 or 1850, 1 by which is equal to 0.000054 the mass, and this is negligible. So electrons have negligible mass. Protons have 1, neutrons have 1, but electrons have negligible mass. So the simplest atom, that is hydrogen. Hydrogen has 1 proton. For example, hydrogen has 1 proton and in the nucleus that is present in it, and it has no neutrons and 1 electron. 1 electron and 0 neutrons that is present on the hydrogen. So the relative mass on the hydrogen will be 1. Okay. और जो है वो next we have a simplest atom, that is of helium. Helium has 2 protons, 2 neutrons and 2 electrons are present in the helium. Helium is the second simplest element that is present in our periodic table, and it has 2 protons and 2 neutrons and 2 electrons are present in the helium. So all the atoms contain the electrically charged particles. The atoms themselves are electrically neutral because overall they have no charge. This means in an atom there are equal number of protons and electrons that cancel out each other. So the total positive charge on the nucleus due to the protons is balanced by the total negative charge orbiting around the electrons. As you can see here in the example of hydrogen and helium, hydrogen has 1 proton and 1 proton, 1 proton and 1 electron, so there is no overall charge. And in case of helium, helium has 2 protons and 2 electrons, so no overall charge will be present on the helium. So in case of atoms which contain electrically charged particles, the atoms themselves are electrically neutral because they have equal number of protons and the neutrons that are present in it. I'm not talking about the cations or the anions, I'm just talking about the atoms that are present here. So this is about the this is all about the atomic structure of the different elements. Next, I'm sharing with you the example related to the structure of the helium atom. So in case of helium, you can see here this one is some nucleus. Nucleus as the helium contains the 2 protons, so 2 positive charges are there, and these will show the neutral charges that are present due to the neutrons, and in the shells that are present around the nucleus we have 2 electrons. These are the electrons that are present in case of the helium atom. So you can see here helium has 1 electron, this 1 electron has -1 charge and this one has -1 charge, so total -2 charge is present on the due to the electrons, and +2 charges present inside the nucleus due to the protons, so they will cancel out each other. But if we talk about the relative mass, charges will cancel out each other, and if we talk about the relative mass, 2 protons has the mass which is equal to 2 units, and 2 neutrons also has the mass that is equal to 2 units. But in case of electrons hardly any mass, negligible mass, as I already told you earlier. Negligible mass is present just because of this 1 by 1840 हमारे पास mass होता है of the 1 electron, so negligible mass is there. So helium atom has a total mass of 4 units. So you can say that 4 units is the total mass that is present in the helium atom. In case of hydrogen we have 1, and in case of helium we have 4. So next we'll move towards the proton number and the mass number. First of all, we'll discuss about the proton number. Proton number is also called as the atomic number. So you can call it as the atomic number or the proton number. We'll discuss separately about the proton number and the mass number or the atomic mass. So first of all, we have the proton number, which we call it as the atomic number, or also the proton number, which is the number of protons in the nucleus. This is the number of protons that are present inside the nucleus. Number of protons that are present inside any nucleus, we call it as the number of protons. Like you can see here in this picture of the atomic structure, we have 3 protons or 3 positive charges are there. So atomic number or proton number of this element will be 3. So this is about the proton number, and the symbol for the atomic number or the proton number is Z. This is represented by the symbol Z, and the number of electrons that are present in the neutral atom determine the position of the element on the periodic table. Mostly in case of atoms that are electrically neutral, they have equal number of proton number and the electron number. So proton number and the electron number are equal to each other of the elements that are electrically neutral. So the number of electrons present in any neutral atom determines the position of the element on the periodic table. So the atomic number is the element of an element is the number of protons in one atom of that element. For example, we have carbon. Carbon has the 6 protons, which means the atomic number is 6, and the atomic number of carbon is 6, and it is also known as the Z equals 6. Z is a symbol for the representation of the atomic number. Next we'll move towards the mass number. Mass number, which is also known as atomic mass. Mass number or the atomic mass of any element. So the mass number is also known as the nucleon number and the atomic number. Nucleon means nucleon that is present in any atom. Like this is the nucleon. Nucleon means in the nucleus we have 2 different particles. First one is the protons and the second one are the neutrons that are present here. So you can say that the atomic mass or the nucleon number or the mass number is the total number of protons and the neutrons that are present in the nucleus of any element. So this is about the mass number, and the mass number is also known as the nucleon number. For example, in case of mass number, we have the example of again the carbon. Carbon has 6 protons and 6 neutrons that are present inside the nucleus, and so the total mass number of carbon will be 12, and this is represented by the symbol A. Mass number is represented by symbol A. That means carbon has the 12 atomic mass. Atomic mass of carbon is 12, means 6 protons and 6 neutrons are present in the nucleus, and the number of particles that are present in the nucleus will represent the number of neutrons and the protons that are present in the nucleus, and this is the mass number or the atomic mass or the nucleon number of any element. So this is about the atomic mass and the atomic number of any element that are present in the periodic table. And periodic table shows the elements together with their atomic number on the top and relative atomic mass in the bottom. Like if there is any element, like for example we have X, any element, suppose we have any element, so on the top left top corner we have the atomic number, and on the lower corner we have the mass number. Like you can see here, A and Z. A is the representation of the proton number and the atomic number, and Z is the representation here, the representation of the proton number. Z is the atomic number, you can see here, and हमारे पास A is the mass number, representation of the mass number. So you can see here X represents any element like helium, He, helium, which has the atomic number of 2 and the mass number will be 4 because 2 protons and 2 neutrons are present there in case of helium. So using this format, an atom of helium can be represented by using this format. You can also use this format for other elements like for lithium. For lithium we have the 7 and the 3. 3 is the proton number or the atomic number, and 7 is the mass number of the lithium atom. So when the proton and the mass number are known for the elements, you can easily work out the following by this one. For example, if you know the proton number Z is equal to the number of protons, and A is the number of protons plus the number of neutrons. Protons plus number of neutrons that are present in the nucleon of an element. So it is also possible to establish other two important relationships from this, like if we want to calculate the number of electrons will be equal to the number of protons in the atom that is electrically neutral. Number of protons equal to the atomic number or proton number. So the number of neutrons will be equal to the mass number. You can find out the neutron number by differentiating the mass number from the atomic number. N equals A minus Z. So by subtracting atomic mass from the atomic number, you can get the number of neutrons of any element like helium. For example, helium has 4 and 2. 2 is the proton number and 4 is the atomic number. So 4 minus 2 means 2 neutrons are present in the nucleus of the helium. So this is all about the proton number and the mass number that is present here. In our book we have different composition and the structure of the atoms of different elements. Almost 10 to 15 elements are present which have the proton number symbol, mass number in our book. So you can check the atoms with their proton number and the mass number from our book. So this is all about the periodic table and the atomic mass and the atomic number. The atom of an element is defined by the number of different subatomic particles that are present in the atom, and the most important number is the proton number that defines which elements belongs to. And next we have the atomic mass, which we have discussed already. So this is the example of the and all discussion about the atomic mass and the atomic number. Next we have another topic which is about the isotopes. Next we have isotopes. So first of all, the definition: isotopes are the different atoms of the same element that have the same number of protons but different number of neutrons that are present inside the nucleus. Isotopes of the same elements have same chemical properties but they have different physical properties. So first of all, we'll discuss about the definition of the isotopes, which I had already told you Now they are the atoms of the same elements that have same proton number. The proton number is the same, but there is a difference in the number of neutrons. Just the neutron number different neutron number. If they have same proton number, then that means they also have the same electron number, or the number of electron are also the same. They are the atoms of the same element. For example, hydrogen. We can take the example of the most simplest element, which is the hydrogen. Hydrogen has total 3 isotopes. For example, the isotopes of hydrogen, first. This is the first isotope, atomic mass and atomic number. This is the second isotope, which has different, as the atomic number shows the number of protons, so the atomic number of all the isotopes of hydrogen are same, but there is a difference in the proton number, but there is a difference in the neutron number that is included in the atomic mass. So you can see here we have the same proton number or the atomic number, just difference in the atomic mass, because atomic mass consists of the number of the protons and the number of neutrons. These are the isotopes of the hydrogen atoms, and these are the atoms of the same elements. First isotope is hydrogen. Second, we have the isotope of hydrogen, which we call it as deuterium, and third we can call it as the tritium. So these are the 3 isotopes of hydrogen. These 3 isotopes of hydrogen have difference in their neutron number. Like you can see here, this is the proton number and the electron number. So all have same proton number and the electron number. First we have 1 proton plus 1 electron, 1 proton and 1 electron, like this. Second, if we want to calculate the number of neutrons, what you can do, you have to use the formula n equals, for finding the number of neutrons, A minus Z. A is the atomic mass and Z is the atomic number. So in the first isotope of hydrogen, we have the atomic mass. Atomic mass is the upper one and atomic number is the lower one. So A minus Z, 1 minus 1, that means 0. No neutrons are present in the first isotope of hydrogen, so 0 neutrons. In the second, 2 minus 1, so we have 1 neutron. In the third, we have 2 neutrons. So you can see here there is a difference in the number of neutrons. First isotope of hydrogen has 0 neutrons, second has 1 neutron, and third one has the 2 neutrons. So isotopes differ in the number of neutrons, or you can generally call it as the difference in the number of atomic mass, not in the atomic number. So these are the correct, this is all about the isotopes, and next we'll discuss the isotopes. Isotopes differ in their physical properties, right? There's a difference in the physical properties of the isotopes, but not in the chemical properties, because chemical properties are related to the chemical bonding, and when atoms form the chemical bond, only electrons are involved, not the neutrons and the protons. So isotopes are different atoms of the same elements that have the same number of protons, so they have the same chemical properties because they have the same number of electrons, so they have same electronic configuration. All have the same electronic configuration, but difference in the number of neutrons only. So isotopes have different physical properties that include the mass, that include the charge. So they have different mass and different charge, so they have different physical properties just because of the difference in the number of neutrons that are present there. So in case of the symbol of the isotopes, it can also be written with the chemical symbol and the proton number, like you can write here as hydrogen 1, hydrogen 2 and hydrogen 3. Another example, we have carbon 12, carbon 13 and carbon 14. This is the symbol, that is chemical symbol, that is used for the protons. And also for the electrons, for the isotopes, carbon 14, carbon 12 and carbon 13 all are the isotopes of carbon. This 14 represents the atomic mass of any element of the carbon, 13 is the atomic number of carbon 13 isotope, and 12 is the atomic number of carbon 12 isotopes. So next we will move towards the calculating the relative atomic mass or relative abundance of the isotopes. So most of the elements exist naturally as a mixture of isotopes. So therefore the value we use for the atomic mass of an element is the average charge. So this takes into the account of the relative abundance of all the naturally occurring isotopes. If a particular isotope is present in high proportion, it will make a large contribution to the average, and this average value for the mass of an atom of an element is known as the relative atomic mass or relative abundance. So the existence of isotope also explains why the accurate value for the relative atomic mass of most of the elements are not the whole numbers. So however, to make the calculations, the values are rounded to the nearest whole number, and this is the example through which we'll do the relative abundance. So now we have the topic which is related to the relative abundance of the isotopes. This topic is related to the isotopes. So in this topic we'll discuss about the relative abundance or calculating the relative atomic mass of any element or of the all the isotopes that are present here. So to calculate the relative atomic mass of an element from the isotopes, we can have two things. The first one is about the relative mass of the isotopes. You should know about two things. First one, relative mass of isotope. You should know about the relative mass of isotopes, and the second thing is abundance of each isotopes. Abundance of that is present in the percentage. Abundance of each isotope. For example, hydrogen has 3 isotopes, so you should know the abundance of each isotope of that are present in any element. So we have some formulas through which you can calculate the atomic mass of any element from the isotopes. So for now we'll move towards, or I will discuss with you first of all the symbol for calculating the relative atomic mass. The symbol for calculating the relative atomic mass is AR. AR is the symbol for relative atomic mass. AR is the symbol for the relative atomic mass, and this is the average mass of the isotope of an element compared to the mass of the atom of carbon 12. So relative atomic mass is the average mass of the isotopes, and also the mass number is not the same. So relative atomic mass takes isotopes into the account while the calculating. So we have a simplest formula through which you can calculate the relative atomic mass, which is AR equals percentage or the relative abundance of any isotope, or you can say the percentage or relative abundance of first isotope or isotope 1 multiplied with the mass number of isotope 1. Mass number is represented by A, so mass number plus you have to add this into the percentage or relative abundance of second isotope plus the, or not plus, you have to multiply it with the mass number of second isotopes, and then you have to divide all this with the 100. So this is the formula through which you can find out the relative atomic mass of any element. For example, now this is the formula through which you can calculate the relative atomic mass. Now we'll calculate the relative atomic mass of any element. Like we have the example of lithium. In the question, you have two isotopes of lithium, like lithium 6 is the 6,3, and plus we have lithium 7 and 3. So you can see here these are the two isotopes and they have different atomic mass but same atomic number, and the relative abundance of these isotopes are also given. So the relative abundance of the isotope, this one, the relative abundance of the first isotope is 7.5 and the relative abundance of second isotope is 92.5. So you can see here the second one is the most abundant isotope of the lithium, which is the 7,3, and lithium 6 is the just 7.5%. So for calculating the atom mass, you can write the values in the above formula. Like I will show you here. So putting the values in this formula, that means we have the percentage of the isotope 1. The percentage of isotope 1 will be 7.5. So it's 7.5 multiplied by the mass number. The mass number of lithium 6, which is 6, plus you have the percentage of second isotope, which is 92.5, and multiply it with the mass number, which is 7, and then divide it with the 100. So when you solve all these, what will happen? We have 692.5 and then divided by 100. After dividing it with the 100, we have the answer, which is 6.92. So this is the relative atomic mass of the lithium isotopes. So you can see here this value is for the relative atomic mass for the lithium, that can be calculated by using this. We have the mass of the 100 atoms, which we divided with the 100. So this is the relative abundance of the or relative atomic mass of the lithium. You can also find out the relative atomic mass for the chlorine. Chlorine also has the two isotopes, the chlorine 35 and chlorine 37. You can also find out the relative atomic mass of the magnesium 24, which has a relative abundance of 78.6, magnesium 25, which has a relative abundance of 10.1, magnesium 26, which has a relative abundance of 11.3. So by applying or by putting the values in this formula, you can easily find out the relative abundance of all these elements. So relative atomic mass, you can find out the relative atomic mass if you know the relative atomic mass or relative mass of the isotopes, and also the abundance of each isotopes. So this is all about the isotopes. Next we'll move towards the third topic, which is third content of our chapter, which is about the electronic configuration. So the last content of this chapter is electronic configuration. Electronic configuration by using the diagrams called the electron shell diagrams, that is called as the electronic configuration. Electrons orbit the nucleus in the shells that have their different energy levels. So we can find the electronic configuration through that. So first of all, you should know about that there are electron shells that are present in the elements, like you can see here, this is the atomic structure, and there are the shells that are present here, and these shells in which electrons revolve around the nucleus. Electrons fill the shells, starting with the one closest to the nucleus, and then it will be moved towards the next one. So a simplified version of the atomic theory of the arrangement of electrons can be summarized by: electrons orbit around the central nucleus of the elements, like this is the nucleus, and electrons will be orbiting around the nucleus in different shells, or we can call it as the energy levels. Electrons orbit and called as the electron shells. These are the electron shells, and shells are further from the nucleus that have the high energies. Shells are filled starting with the one closest to the lowest energy, that is from the closest to the nucleus. The one which is closest to the nucleus has lowest energy, which is closer to nucleus. Shells have different energies, so the one which is closer to the nucleus have lowest energy, and the one which is further away from the nucleus has the more energy. So second and the subsequent shells can hold 8 electrons, and they to give the stable electronic configuration, but per shell can accommodate or can have the capacity to hold just 2 electrons. Second and the subsequent shells can accommodate 8 electrons in their shells. So the different energy levels in an atom: electrons fill the shell starting from the one closest to the nucleus. The one which is closest to the nucleus has lowest energy, and the one that are moving further away from the nucleus have increasing energy levels from the nucleus. So for the next, we will discuss about the electron shell diagrams. Electron orbit around the nucleus in different shells. Electron fill the shell which is closest to the nucleus first, and then electrons fill the second shell and then the third shell. So first shells can hold 2 electrons, second shell can hold 8 electrons, and for the first 20 elements the third shell and above can also hold, but this is the simplest ones. So the outer shell is called the valence shell. The outer shell of any element is known as the valence shell. Valence shell is the outer shell of any element in which electrons are present. And also bond, if we talk about the chemical bonding is just with the valence shell electrons or the outer shell electrons that are present there. So the arrangement of electrons can be explained by writing the number of electrons in each shells, and also by separating the commas. This is the electronic configuration of any element. Like if this is the atomic structure and there are 2 electrons in the first shell and 8 electrons in the second shells. So this is how you can write the electronic configuration of any element, like 2 in the first, comma, and then 8 in the second shell. So the arrangement of the electrons can be explained by writing the number of electrons in each shell and separating by the commas. This is the electronic configuration. For example, we have the example of lithium. Lithium is the third element in our periodic table, and the proton number, the electron number of the lithium is 3. So this is lithium atom. This is the first shell and this is the second shell. First shell has the capacity to hold the 2 electrons, so there are 2 in the first, and second shell has the capacity to hold 8 electrons, but only 1 is left, so there will be 1 in the second shell of the lithium, and the electronic configuration for lithium will be 2, 1. So this is how you can represent the electronic configuration of an element that is present in our periodic table. Electronic configuration of any element, like for example carbon has 6 electrons, so 2 in the first shell and 4 of which in the second shell. So the electronic configuration will be 2, 4. Group 8 elements are also known as the noble gases, and they have full outer shell, meaning they are unreactive. The number of the outer shell electrons is equal to the group number, and the number of the electron shells is equal to the period number. In our periodic table, we have groups and the periods, like you can see here, groups and periods in our periodic table. Total 7 periods are there. These are the periods in which elements are present. Total 7 periods are there, and the number of electron shells that are present is equal to the period number. Period number represents the number of electron shells that are present in it. For example, first period has hydrogen element and helium. That means there is just one electron shell that is present in the atom of the helium and the hydrogen, because hydrogen has only one electron and helium has two electrons, so both have just one or the first shell. And the elements that are present in the second period have two electron shells, two shells that are present in the structure. Third period have three shells, fourth have four shells, fifth have five shells in their structure. So if we talk about the groups, the number of outer shell electrons or the valence electron is the group number. Like in the first group, in the group 1, periods are the horizontal and groups are present in the vertical. So this is the group 1, 2, 3. In the first group we have hydrogen, we have lithium. That means there is one valence electron that is present in the hydrogen and in the lithium. Hydrogen has only just one electron, lithium has three. So that means the valence electron of lithium is just one because it is present in the group first. The elements that are present in the group 2 means there are two valence electrons in the last shells. The elements that are present in the group 3, they have three valence electrons in the last shell or in the valence shell. The elements that are present in the group 8 elements, they are known as the noble gases and they have full outer shell. Noble gases are unreactive, that's why they are called as the inert gases, and they do not react with each other because they have full outer shell. So that's why the number of outer shell electrons is equal to the group number from group number 1 to group number 7. From group 1 to group 7, that represents the outer shell or valence electrons of any element. Valence electrons of any element. So this is how the group representation and the period representation in our periodic table. The group number and the period number. The elements in the group have same number of outer electrons, so they have the same properties. From the group number 1 to group number 7, the number of the group is the number of electrons in the outer shell. So if we move across a period in a periodic table, the shell of the electron is being filled. The properties of the elements can be closely determined by the number of outer electrons in the elements, and the elements in the group 2 have two outer electrons or two valence electrons, and the elements in the period 3 have three shells of electrons. So this is the difference, or this is how the group number and the period number indicates. Group number is the number of vertical columns that an element is present in the periodic table, and the period number or the rows are the horizontal rows of the periodic table that an element is present in it. And there is an exception about the noble gases. Noble gases are the group 8 and they are very reactive gases. They are very unreactive gases, and the atoms of the noble gas elements have a very stable electronic arrangement. That means their atoms exist naturally as a single elements. Noble gas atoms do not make the chemical bonds with the atoms of the other elements by sharing or nor by transferring outer electrons. Noble gas have full outer shell electron. That means they have the 8 electrons in the valence shell. For example, we have helium. Helium has 2 electrons. We have neon. Neon has 10, and we have argon, and argon have 18. So that means, so you can see here, or you can easily predict the period number and the group number of these. Helium has 2 electrons in the valence shell. That means 2 electrons in the valence shell, or you can say in the first shell. So there is just one shell, so this is present in the first period. There is only one shell in the helium, so it is present in the first. There's just one electron shell, or helium is present in the first period. If we talk about the neon, neon has the electronic configuration of 2, 8, and there are 2 shells that are present, so the period number will be 2. And for argon, it has 2, 8, and 8 is the electronic configuration. It has 3 shells, 3 outer shell. electrons, so it is present in the third period of our periodic table. So this is how you can easily predict the period number and the group number. Helium has 2 electrons, that means helium is present in the group 2, or you can say that the outer electrons represents the group number. So the outer, there's just one shell in the helium, so this is also the group number. If we talk about the neon, neon is present in the group. There is an exception in case of the noble gases. Noble gases are present in the group 8, right? No, neon is also present in the group 8 because the outer shell is completely filled, and argon is also present in the group 8. So this is there are also the other noble gases in our group 8. Krypton, xenon and radon all have 8 outer electrons in their valence shell. So this is all about the electronic configuration of the different elements that are present in our periodic table. The most important of this is the group number and the period number. The group number is the number of vertical columns that an element is in, and the period number are the horizontal rows of the periodic table. And the noble gases elements are present in the group 8, and they are a group of stable and very unreactive gases. So this is all about the atomic structure, in which we have discussed the atoms, elements, isotopes, and also the electronic configuration of the different elements. So this is all about the atomic structure, or the second chapter of our chemistry notes. And next we will discuss about the third one. If you have any question or any query, you can ask in the comment box. Hope this will be according to your, and we'll meet in the next video, which will be about the chapter number 3. So there you go, that is done. So we have discussed the entire topic related to the atomic structure, and there will be a lot of the chemistry videos related to the chemistry notes. Thank you for watching this, and I will see you in the next one.